Let's take a look examining table 8.1 in Stock and Watson, which is a table of regression results of the return to education and the gender gap. And what we have here is a dependent variable, an outcome variable that is the log of hourly earnings, right? So we've seen that in our various R exercises as the log of AHE. The log is sometimes written as ln and sometimes written as log. There's no standardization for R. Log is the function that takes the logarithm of a variable. So that's our outcome variable, and we can quickly look at our explanatory variables here, and we see on the first page there's no explanatory variables that are logged, and on the second page, if we look at the continuation of the table, there's also no explanatory variables that are logged. So we have a log linear regression, right? So remember, there's three kinds of regressions when we start using logs. There's log-log, log-linear, or linear-log. So this is a log-linear regression. And remember, then we're going to interpret the coefficients as multiply the beta by 100, and that tells us the percent change in the outcome from a 1 unit change in the explanatory variable. So we have 1, 2, 3, 4 regressions here, and we're going to interpret the coefficients. Notice that the first thing we should do is look at the footnote. The footnote tells us some definitions that are essential for understanding the regression. So we shouldn't just jump right away into interpreting the regression. We should take a look at the footnote. Sample size is 52,000. Female is an indicator variable, a dummy variable, 1 for women and 0 for men. Midwest, South, and West are dummy variables for the region of the United States. Midwest equals 1 if worker lives in the Midwest and 0 otherwise. And then notice how helpful. They tell us what the omitted region is. So we interpret the dummy variables, Midwest, South, and West, as the difference on average between person in that region and a person in the Northeast, the omitted category, holding the other control variables constant, like female, years of education, etc. We have standard errors reported in parentheses, so those are standard errors, not the t-statistics, and we have our usual asterisks, 5% and 1%. Notice that it's 1 star for 5%, 2 stars for 1%, and they're not giving any stars for 10%, right? So every table will often have a little slightly varying definition of what the asterisks are signaling for the reader. So that's now that we have a better understanding of what the variables are, we can go back to interpret our first coefficient here on years of education. It's 0.10. So we multiply that by 100. So 0.10 times 100, right? We move the decimal place over 2 times, so we have 10. So for each additional year of education, there's a 10% increase in hourly earnings. So a 10% increase in hourly earnings. So notice we could say it 2 ways and be correct. We could say for each 1 unit increase in years of education, that is for each additional year of education, there's a 0.1035 increase in the log of hourly earnings. So there's an increase in the log of hourly earnings, but of course nobody knows what that means, and that's why we instead use our other interpretation, which is a 1 unit increase in years of education is associated with a 10% increase in hourly earnings. So that way we've gotten rid of the log there. So 1 year of education either means 0.10 increase in log of hourly earnings, or it means a 10% increase in hourly earnings. So that's our interpretation of the main coefficient of interest, what we're interested in. But as the table tells us, we're really interested in whether there's a gender difference in this effect of education on hourly earnings. And so that's what the focus is on this table as we go from regression 1 to 3 and 4. We're examining the gender effect of the returns to education, or the gender differences, or the gender gap in the returns to education. So let's take a look at that as we move across the regressions. But before we do that, let's notice some things about these regressions. The first is that years of education alone, the coefficient barely changes as we have different specifications, right, suggesting that it's not really subject to much omitted variable bias. Even when we include a whole bunch of control variables as we do in the end, the coefficient barely moves, right? So that's one thing to notice. A second thing to notice is that our square doesn't change very much even when we add more control variables, right? So our basic finding that education leads to about 10% increase in earnings is accounting for, right? So we see that just years of education is a really important determinant of earnings. Accounts for about a quarter of the variation in earnings, and seems pretty robust across different specifications. So now we come to the gender effect. So we first introduce female as the dummy variable. So in regression 2, we have years of education and whether you're a female, a dummy variable. And we see that females, we can interpret this as being female means you earn 26% less than males. Males is obviously the omitted category. So there seems like a pretty big gender gap. Notice that two things can be true at the same time. Females can earn less, and the effect of education can be 10% for males and for females. So females earn less, but each additional year of education means they earn 10% more. Males can earn more, and each additional year of education means they earn 10% more. So both things can be true. Our next regression says, well, is there indeed a different effect for females on years of education? So years of education still has this 10% effect. Female, now the gap is even bigger once we control for the female effective years of education. And now we see that when we include the interaction term of female times years of education, it is significant and is positive, suggesting to us that females earn, for each additional year of education, they earn the 0.10 plus the 0.01. So they earn about 11% more per year of education. So the returns to education are slightly higher for women than they are for men. That's what that coefficient is telling us. The returns to education for men is 0.10. The return to education for females is 0.10 plus 0.0121, so it's about 11%. When we include more control variables such as experience and region, we find that they're all significant, but we find that they barely change the coefficients on female and female years of education. So those are robust to these other control variables that we include in the regression. We might think a little bit about these other control variables. So for example, potential experience, we see that it's positive for each additional year of potential experience as you get older is associated with the 1.4% increase in earnings, 1.43. But, right, we can't say that alone because we see that there's a quadratic term here. So the return to experience depends on the level of experience, and we see that the first coefficient's positive, the second coefficient's negative. So our relationship between experience and earnings is going to be and the log of earnings is going to be a quadratic looking like that. So the returns to experience then depend on the level. They're positive here and negative at this end, right? So there's a negative slope there and a positive slope there. And we see that the dummy variables for region all have negative coefficients. People in the Northeast earn more, about 10% more, right? Because people in the Midwest are earning 9.5% less, people in the South are earning 9.2% less, people in the West are earning 2% less than people in the Northeast.